assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for part A from Hooke's law, we have that the spring constant K would be equal to the weight 500 kilograms multiplied by 9.8 meters per second squared divided by 10 centimeters, or we can say, we can keep it as centimeters, so 10 centimeters. This would be equal to 4.9 times 10 to the second newtons per centimeter. Now for part B, we know that the amplitude decreases by 50% during one period. So essentially the damping factor, e to the negative b, the damping constant, times t, the period, divided by 2 times the mass would be equal to 1 over 2, so 0.5, where the period is equaling 2 pi divided by the angular frequency prime. The problem asks us to estimate where the angular frequency prime is approximately equal to the original angular frequency, and so this is going to be equal to the square root of the spring constant divided by the mass m, and so we can say omega prime would be equal to the square root of 49,000, this would be newtons per meter, divided by 500 kilograms, and this is approximately equal to 9.9 radians per second. So we can then say, plugging this into t is going to be equal to 2 pi divided by 9.9 radians per second, and so the period is now equaling 0.63 seconds approximately. We're going to take the natural log of both sides of this equation. So now we have the natural log of e to the negative b times t over 2m equals the natural log of 1 over 2. And so we can then solve for b, and we can then say that b is going to be equal to 2 times the mass over the period times the natural log of simply 2. And so b is going to be equal to 2 times 500 kilograms divided by 0.63 seconds multiplied by the natural log of 2. It's approximately 0.69, but we can just leave it as a natural log of 2. And this is going to be approximately equal to 1.1 times 10 to the third kilograms per second. So this would be our answer for the damping constant. That is the end of the solution. Thank you for watching.